talk about the influence of latitude on our temperature. All right. It has to do again with that solar energy. But let's think a little bit about this. The sun is giganto compared to our Earth. So we'd have a gigantic sun sitting there. And our Earth, really, in comparison to the sun, relatively small. And so here we are, we're out there, we're living our lives, and everything is going on happy-go-lucky. We know that energy is going to be coming from the sun, but energy that comes to us from the sun is almost going to be traveling. Look, they're so small, they're so short waves that they look like straight lines. And so they just come like these straight lines to the Earth. Now, what I'd like to do on the next sheet is kind of take this little picture right here and make it bigger. So that's where we're going to go next. Right now, that way we can draw our Earth a little bit bigger. And we're going to have our solar energy still coming in. I'm going to use yellow for that solar energy. Packets of energy. And because the sun is so big, it's almost as if they travel in parallel lines. When they're coming from the sun, it's almost like this parallel energy coming, just because it's so much bigger than the Earth. And so when we start thinking about sun geometry and other things like that, it's as if it were coming here. Now, here's the weird deal. Check this out, right? And maybe it would even be helpful. We'll bounce back and forth. But think about this energy, and let's say that we're going to the sun sending us a little package of energy, and that little package of energy is going to be coming to the Earth, and that little package of energy is going to be concentrated right in that little area. So it's going to be hitting pretty darn hard. It's straight on. Right now, the same package of energy, let's say right up here, now it's going to be hitting more of a curved surface. Right? So that energy is going to be hitting sort of that region right like that. Notice how we have the same amount of energy, but because of the curve of the Earth, it's being spread over a little bit bigger area. So the concentration of the energy here at our lower latitudes, towards the equator, going to be very, very dense, very, very thick. That same packet of energy is being spread a little bit further in the higher latitudes. Now, we go even higher, and the same package of energy, let's try to draw the same size, that same package of energy is going to be hitting here, but now it's going to be spread even further. Right? Again, because of the curve of that Earth, that same energy is hitting there. If we were to take the same number of dots and spread it across that region, it's going to be even more space in between those. Right? The difference is significant. If we were to look at a good circle and our circle were to be perfectly round, what we would see is that the energy, the same little package of energy that comes and hits right here, it's being spread over 2.5 times. Once we get to the poles, we would have one package here, we'd have one package here, and it's being spread 2.5 times the area impacted by the same energy. So what does that do? Well, we learned that the Earth's energy balance has to do with the sunlight that's coming in and the heat that's radiating back off. So here, there's just going to be a lot more higher concentration Good. And here, the same energy is going to be spread. Oh, man. Spread. There we go. We'll imagine that that's just a really creative A. Spread further. Lower concentration of light. Okay, if you go to Hawaii, it's going to be sunny and warm just about every day. If you go to Alaska, it's going to be significantly different. Now, the one thing that we will see that has a little bit to do with seasons, we've talked a little bit about this. Here, it's going to be, for our seasons, we're going to see 12 hours of day, 12 hours of night all the time here at the equatorial areas. As we go further and further north, Winter is going to be so cold because the sun, we have a low sun angle, meaning the sun is low in the sky. It never comes up that high, right? So low sun angle and shorter days. So this has a little bit more to do with the seasonality of these areas, but that is definitely going to be what we see. So with the low sun angle, the sun low in the sky, right? I'm standing, and the sun is going to be, even at noon, it's going to be a lot lower compared to here. The sun would be directly overhead. Right? So we have our low sun angle, and in the wintertime, we have very short days because of the curve and the turn, the spin and everything. The days get very short in here as well.